Okay, so when we take a look at the Okotoks assignment, starting off on identifying the main limitation and benefits of solar energy, explain the difference between passive and active solar systems. So when you're taking a look at this, the use of solar radiation comes from the ancient concepts, but in recent the impact of burning fossil fuels has been a hot topic, as we can discuss right now. Modern solar system energy technology harness heat generated from the sun to power residential and industrial and cooling systems throughout the use of photovoltaics, PVs, and panels. So that's one of the benefits of what they were doing in Okotoks, and I'm assuming that you've already watched the video, so keep that in mind. Also known as solar cells, these devices capture and convert solar into electrical energy. How is this energy collected and distributed, and define the difference between active and passive? So when you take a look at their designs, they've got passive, which has this is not the same as talking about solar panels. Okay, passive solar does not use mechanical device or a conventional source, but needed to regulate dampers and others to control. If any of the classic example of basic passive solar structures such as greenhouses, sunrooms, solariums, sun passes through a glass, the interior absorbs and retains the heat. So it's basically redesigning their houses to basically absorb energy into their house. Okay, so that passively the energy comes in and it's redistributed. The heat gets redistributed and then it stores in the walls or the concrete of the floors and in the house. Now your designs, once again, south-facing windows, although some systems may also use some PV panels. They might have a solar wall, which basically absorbs huge amounts of energy and then basically moves from warm to cool areas. The simplest method is to transfer heat from a passive solar collector through convection, illustrated in a sunroom or a southern wall that rises to an area where it's cooler. So you can see in this passive solar design here, the energy comes in from the sun, absorbed into a concrete floor. There's insulation that traps the heat, and there's insulation here which basically keeps this energy within the house. Now they have a low overhang because you have winter sun, which is fairly low, and the summer sun might be too hot, so you don't want to get too much energy coming in, so it restricts the amount of energy coming in to the house during the summertime. And in the wintertime, because there might be, the trees are typically on the north side, and then also on the south side, or sorry, west side and south side, and they typically pick deciduous trees so that the leaves come off in the wintertime to allow as much energy to come in. They might use some deciduous trees to block off excess amounts of energy coming in, otherwise the house will get too hot. Then when we take a look at active solar heat uses external sources such as blowers, pumps, and other equipment to collect and store converted solar heat. Okay, so you might have a solar wall that's right here, and then from there, the small system used to furnish electricity to heat and cooling systems, while large systems can furnish power for an entire community. Okay, and that's what they ended up doing in the Drake Landing area. The active solar, the collectors are more complex, both in design and mechanism. They consist of flat plates of PV panels, usually mounted to remain stationary, and designed to track through the course of the day. In some design, multiple panels are connected together to form a module. Active solar heat contains either an air or a liquid as a conductor. Those air is referred to as an air collector. Liquid is as a hydronic collector. The advanced designs of these collectors make an active heating more cost-effective, reducing reliance on traditional sources. Now this is where it gets kind of interesting. You might have the collectors on the roof, which you can see right here. So they heat up, they get the sun's light, they heat up, and then the warm energy gets pushed down, the cooler gets replaced and comes up, heats up, and then that fluid that's typically an antifreeze gets moved into a furnace, and then there's a heat exchanger. So the hot air gets transferred into the furnace, and then that energy is then transferred into in-floor heat or into a blower motor, which then pushes the heated energy into the air and then throughout the house. Now, after its energy has been transferred, it goes back into the heat exchanger over here, gets redistributed into here where it's cooler because the energy has been taken off of here. Okay, so the energy from the sun causes this circulation, then it moves here, moves across, transfers the energy into the furnace distributes it into the air ducts, and then the cooler fluid moves back into the system. So the first question they have about Okotoks is to identify the natural source resource that was chosen when the town of Okotoks limited the maximum size. It's the water from the Sheep River as the resource is used to identify the growth of Okotoks. It will not go any bigger than the water can from the Sheep River can either maintain or control. Describe some of the strategies used for the long-term sustainability of the resource identified in your question number 1. To ensure the long-term sustainability of the water, the per capita consumption has to be reduced by 30%. Citizens who use more additional water have to pay more if they have any additional water usage. In addition, the municipal officials are able to track 95% of the water's use. Improvements are also made from sewage to ensure that the water is returned to the Sheep River and a similar set of water qualities than it was originally removed. When you identify the renewable technology used to meet the energy need of the municipal buildings in Okotoks, the renewable energy technology used to meet the municipal buildings in Okotoks were included with wind energy, so little turbines, and solar thermal energy, which we talked about earlier. Describe how the design of municipalities allowed for the renewable energy technology to be used. The design of the municipalities were adapted to allow installation of large panels on the side so the solar energy can be collected to preheat intake air. That's the active. And specialized solar collectors have been placed on the roofs of buildings such as hot water for a community for the swimming pool and for the heating inside the building. For those of you who've been down to Okotoks, you've probably been to the rink there and the community center, and that's the most common one that you've seen. Okay, when you describe other features of the homes in Drake Landing Solar Community that enabled to reduce the annual greenhouse emissions, the homes at Drake Landing are all R2000. They have a high level of insulation and more efficient furnaces, and they also use less energy. The electrical devices in the home include appliances and fixtures that are also based on energy efficiency. The other one was the houses have the big field, which has massive amounts of geothermal, which transfers heats off the connected community garages under the sports field, and that energy is then stored until when they need it on cold days.